Hello students, today we're going to look at 8.3, sorry my head's in the way, rotations. Rotations is the third transformation that we've been studying. We started out with translations, sliding something across. Then we did reflections, which is a mirror image over the x-axis or the y-axis. And then rotations is what we're doing now. There's a lot to rotations because there are 4 different types of rotations. And so we're going to look at each one. Now I'm going to have a chart paper with a triangle here, triangle ABC. Again, you don't have to write down the triangles, but I do want you to write down the other stuff that I write, okay? And you're welcome just to fill it in on that foldable that I created for you, and you have that. Or you can just write it down in your notes in a column or something, and then we'll put them in the foldable later, okay? So we're going to talk about rotations. First of all, I've got to start with an original figure. I have a triangle here. My triangle is triangle ABC. You notice it's a right triangle, nothing special. Between A and B, it's 6 units. Between A and C, it's 4 units. And then we connected the hypotenuse between B and C, just a triangle. What I'm going to do now is rotate this triangle lots of different ways so that you can see what a rotation looks like. Now, a rotation, the definition is a figure is turned about a fixed point, and both figures are congruent. They're turned, rotation, but they're still congruent, okay? So we have right here my original figure, and it's in blue, okay? So next, I'm going to look at this green figure that is rotated 90 degrees clockwise, which is exactly the same, and you need to know this, 90 degrees clockwise is exactly the same as 270 degrees counterclockwise. And just in case you're unfamiliar, clockwise means it goes the same way the hands on a clock go. Okay? So if the hands on a clock go this way, then I'm going 90 degrees, but 270 degrees. That means I'm going counterclockwise. So from here, I go around 90, 180, and then 270 degrees backwards, basically, is counterclockwise. Okay? But we're going to deal with 90 degrees counterclockwise, but it's exactly the same as 270 degrees clockwise. Now, the algebraic expression for 90 degrees clockwise is x comma y, arrow, here's where it's tricky, y comma negative x. Okay? So, what does that mean? I'm going to just look at point B. Point B is negative 1 comma 7. Okay? Negative 1 comma 7. Now point B prime that I've already drawn on here is 7 comma 1. So if we look at this, if the original is negative 1 comma 7, then what I do is I flip the place of those and the y comes first, so the 7 comes first, and then I take the opposite of the x. Well, the x was negative 1, and so I take the opposite of that, and I get positive 1. So that's why the algebraic expression is x comma y to y comma negative x. Yes, you're going to have to memorize these and know them. Okay? So that's what I want you to write down for 90 degrees clockwise and 270 degrees counterclockwise. Now, so we don't get confused and all messed up, I'm going to cover this back up. And we're going to go back to our original figure. Now, our original figure is here, ABC. Okay? So now, let's look at this rotated. This rotation is 180 degrees clockwise. And I bet you've already figured this out, that 180 clockwise is exactly the same as 180 degrees counterclockwise. Okay? So I'm going to lift this up a little bit. Actually, I'm going to angle the camera a bit. So this is the same as 180 degrees counterclockwise. So let's look at B. B is 1 negative 7. B double prime. 1 negative 7. Okay? So let's look at how it changed. So the 1 and the 7 are in the same place. They're just both opposite of each other. So the algebraic expression is x comma y arrow negative x comma negative y. Again, we say negative, but it actually means the opposite of x and the opposite of y. So whatever my original x and y was, if I need to know a 180-degree rotation, then it's going to be the opposite of that x and the opposite of that y to give me the new point, or in this case, be double prime. I put double prime on here because this is the second rotation. Didn't want you to get confused. Okay? Again, this is what I need you to write down. 180 degrees counterclockwise is the same as 180 degrees, start over. 180 degrees clockwise is the same as 180 degrees counterclockwise, and the algebraic representation is x comma y, arrow, negative x comma negative y. If you need to pause and write that down, you can. So we're going to cover this one back up so we don't get confused. And now we're going to look at this one. Okay? So if we went from this original here, we did 90, and then we took that original and we went here and we did 180, then we're going to go here to this orange one. From the original is 90, 180, 270 degrees clockwise. And I know y'all are smart folks, so you've already figured out that 270 degrees clockwise is exactly the same as 90 degrees counterclockwise. So if you look at our original, if we just went 90 degrees backward, that's the same as 90 degrees counterclockwise. Or we could go 90, 180, 270 to 270 degrees clockwise. Okay? So let's look at B triple prime. I did the triple prime just because it's the third rotation. And so B triple prime is negative 7, negative 1. So what changed? Well, the first thing you probably noticed is that I had negative 1 comma 7. Now I've got negative 7 comma negative 1. So we know that the order changed. Okay? So my algebraic expression is x comma y arrow, and I know that the y is going to come before the x. Okay? But what else do I know? The y was originally 7 and now it's negative 7, so I've got to find the opposite of that y, or the negative of y. The x number stayed the same, so it's just going to be x. So the algebraic representation for a 270 degrees rotation clockwise is x comma y arrow negative y comma x. That's what I need you to have written down. Okay? We're going to do some activities in class that let you see this and put it in your composition book. It's going to be really cool, so you are able to manipulate and find your own. But I just wanted to make sure that you had these algebraic representations written down from this video so we can launch into that activity as soon as we get to class. So I'm going to stand here and just introduce, you have 2 practice problems, really quick, and here they are. For number 1, I want you to assume it's a 90 degrees clockwise rotation. Original point B is 3 comma 7. What would B prime be if I did a 90 degree rotation? For number 2, let's talk about 180 degree rotation counterclockwise. And if R is negative 4 comma 3, then what is R prime based on the algebraic representation of a 180 degree counterclockwise? So do those 2 problems, take a picture of it, submit it through Edimodo, and you're finished.